In this short video tutorial, we will be discussing how to fit non-parametric copulas to historical data with ModelRisk. The fitting of non-parametric or empirical copula to historical data is a function completely unique to ModelRisk and certainly unique to risk analysis software in the Excel environment. Before you view this video, I'd encourage you to first have a look at the overview of all types of fitting in ModelRisk, which is another tutorial, and also a tutorial about the fitting of parametric copulas, as that will be a good background for this demonstration. What we have here are 4 random variables. We have 1,000 samples from each random variable, and what we'll do is imagine that each set of 4 random variables were sampled at the same point in time. And so the question always is in risk analysis is whether random variables who occur at the same point in time or location, whether those are correlated or not. And it's very important because if they are correlated, it's critical that that correlation be represented in the risk analysis model being built. So in ModelRisk, the correlation facility that we have are called copulas, very sophisticated mathematical technique, which is made quite easy to use here in ModelRisk. So we can first select our data. We'll go to the Fit button. As you may have surmised, there is both a parametric and a non-parametric copula available in ModelRisk. We'll first look at the parametric copula. There are 5 different types of parametric copulas. We'll select them all, let ModelRisk fit the data to all those copulas. What ModelRisk is essentially doing is finding the type of copula and the actual parameters that most closely fit the correlation structure in our historical data. In this case, ModelRisk has determined via information criteria that the T copula is the closest fit. We can add some labels to our fit window so it's a little easier to see the correlation as it applies to our variables. So let's first have a quick look. We can use the fitting window to have a quick visual look at the different kinds of correlation. And so we'll first look at variable A versus variable B. We see this very broadly scattered visual graphic, which implies that there is a very low correlation between these 2 random variables. If we look between A and C, we notice something very interesting. Let's just look at the data alone. If we look at the data alone, we can see there is clearly some kind of relationship between variable A and variable C. We've got this strong line here that kind of scatters as we go up and to the left, and then we've got a scattering of correlation down in the lower right-hand corner. But if we show the copula that's best fitted to that, we can look at them together, we can see that for the T copula does not well fit this particular correlation structure, which is a bit concerning because we want to be able to represent the correlation as accurately as possible in our model. Let's quickly look at A versus D. Not much. Then let's have a look at B versus D. We see a very close correlation, and so for this correlation structure, here's the data, and here's the data and the fitted copula together. We can see that the T copula can quite closely fit this particular correlation structure that's largely linear but is very pinched at the ends. So we've got a little bit of a problem. We can represent the B-D correlation structure quite closely, but we're unable to represent the AC correlation structure closely. So we're not going to use our parametric copula. What we're going to do is now try the empirical copula, which is taking its shape exclusively from the data, from our historical data. Let's go ahead and add the labels so we can compare to what we saw before. If we now click the AB, again we see very little correlation. If we click AC, we can see now we have our data in the red, and our fitted copula in the blue very closely fits our data. This is actually the inverse of the picture we were looking at before. There's the same picture we were seeing before. So clearly what we want to use is the empirical copula to be able to represent this correlation structure. Let's look at the BD structure and see if that also works. And in fact, this also works to represent our structure between B and D, which we could have used the T for, but the AC structure just wouldn't work. So let's go ahead and we'll put this copula into our spreadsheet model. Click OK. We now have our correlation structure in the form of a copula entered. I earlier fitted an empirical or ogive distribution to all of our random variables. And then what we can do, if we now have our fitted copula correlation structure and our fitted non-parametric distribution, we can use the Vose simulate functionality, where we simply simulate from this distribution object, and we use the U parameter, which is this last parameter here, to correlate all four of these. So we now have, every time we recalculate the spreadsheet, a random sample from each of our four random variables that are fitted to our historical data, but we also are maintaining the correlation structure that is built into our historical data. So if we were to run this to kind of verify these results, I ran a simulation earlier. We can look at some results. We can see here is our our AC correlation structure. This is the copula itself. And here is a scatter chart from variable A versus variable C. We can see that we very closely recreated this structure, as we have between B and D, which was close to that T correlation structure that we saw earlier. So what we've been able to do is not only recreate the structure that well fitted the parametric distribution, copula, we've been able to recreate the correlation structure that is nonlinear and is impossible to recreate using a parametric copula. So again, what I'll mention is this functionality completely unique to ModelRisk, and not only is it unique to ModelRisk, but we're implementing a very sophisticated technique in a very quick and easy fashion that helps the modeler or the analyst quickly build transparent, fast simulating, and easy to understand risk analysis models while maintaining that high level of mathematical sophistication. If you'd like to learn more about copulas, both parametric and non-parametric, I'd encourage you to have a look at the ModelRisk help file. If you don't have a copy of ModelRisk, I'd suggest you go to the vosesoftware.com website and you can download a free, fully functional 30-day trial. The help file for ModelRisk is also available on vosesoftware.com, an online version, so you need not even download a copy of the trial software to have a look at the help file, which is essentially a 500 topic plus risk analysis textbook. If you have technical questions or sales questions about ModelRisk, or you'd like to learn more about fitting copulas or perhaps get this particular example model, please contact our sister company, Vose Consulting, at these numbers or online via www.voseconsulting.com.